Hey class, this lesson is an introduction to thinking about ratios for 6th grade. We will be understanding the concept of a ratio and use ratio language to describe a ratio relationship between two quantities. We'll also be focusing on MP2, reasoning abstractly and quantitatively. Today, I want you to refresh your memories about what you know about fractions. If I have 7 apples and 5 oranges, how could this be represented as a fraction? When we have apples and oranges, we have to think about the number of apples to the total number of fruit, or the number of oranges to the total number of fruit. We cannot make a fraction out of apples and oranges. This is a part-to-whole relationship. So, let's look at some different ways to represent this scenario with virtual manipulatives. Here are some websites you can go to find some different ways to represent these. I'll give you a few examples. I am liking this fractions manipulative. You can choose your shape if you like circles, or you can choose rectangles and cut them into strips. So here's an example of we have 12 pieces of fruit. So I'm going to put 12 here and 12 here. Okay, oops. I think I need to try that again. Let's try that circle again. Okay, there we go. We have 12. So right now it says I have 0/12. So when we're thinking about our apples, I need 7. Okay. Okay, I'm going to copy that. How many oranges? 5 oranges. Okay. So this is just an example of a way you could use these to represent those fractions. All right. Turn those back. Oops. So you can play around with these and see which way you prefer. There's also some Unifix cubes and 10 frames that you might consider showing different ways to show these relationships. Okay, so here we have our 7 apples, our 5 oranges as compared to the total number of fruit. Okay, so our 7 apples and 5 oranges, there's 12 total pieces of fruit. This is our part to whole relationship. 7/12 represents the part to whole. So our ratio would be written 7/12. For 5/12, our ratio would be 5/12. Now let's move on to part-to-part relationships. 7/5 is the ratio that represents the part-to-part relationship between the two types of fruit. For every 7 apples, there are 5 oranges. If we were to double the number of apples to 14, how many oranges would there need to be to keep our comparison the same? We would have 10. A ratio is representing the relationship between apples and oranges, parts to part. When thinking about the total number of fruit, we think of the ratio 7/5 as a composed unit, meaning that when the number of apples increases by 2 times more, the number of oranges also increases by 2 times more. The part-to-part ratio 7/5 can only be represented as a fraction only if using a multiplicative comparison. A multiplicative comparison means there are 7/5 more apples than oranges, or the amount of oranges is 5/7 of the amount of apples. So let's say, before we move on, let's say we had a box of 16 apples to a box of 9 apples. our ratio would be 16 to 9. If we think of this as a multiplicative comparison, meaning the box of 9 apples can be compared to the box of 16 apples as 9/16, or can be thought of as how many times greater is the box of 16 apples than the box of 9 apples? It is 16/9 greater. So far, we've discussed part-to-whole ratios, which can be represented as fractions, and part-to-part ratios, which can be thought of as composed units or multiplicative comparisons, depending on the information you're seeking through the relationships. Let's practice creating ratios and analyzing relationships within and between ratios using the following examples. If you have a bag of candy with 4 orange candies for every 3 yellow candies, write the ratio. Here you may want to use your Unifix cubes. 4 orange for 3 yellow. Okay, if we have 77 candies, how many orange and how many yellow candies do you have? How do you know? Pause the video and think. So if we apply what we know about the total number of candies, which was 7 to begin with, now if we have 77 pieces of candy, we know that our original amount increased by 11 times more. The units within the ratio are composed units. That means if the orange candies increase by 11 times, the yellow candies will increase by 11 times more as well. Number 2, a grocery store charges $1.30 for 1 box of onions. Write the ratio. If your neighbor bought 8 boxes and you bought 3 boxes, what ratio language represents a multiplicative comparison? Here, I would say my neighbor bought 8/3 more boxes than I did, or I bought 3/8 as many boxes as my neighbor. Now it's your turn to do some practice. Use the virtual manipulatives and the examples to complete the questions.